How to use bond energies to calculate the energy transfer of higher content. So to calculate the overall energy change, what is the equation? In the chat section, I've already told you. How do you calculate energy change? Overall energy change, what is it? How do you calculate it? Excellent. Thank you, Marcel. Thank you, Vivek. Total energy in, take away total energy out. So it's total energy in, take away total energy out. Now this is in joules per mole. Now remember, when it comes to the total energy in, this is about breaking the bonds. The total energy in is used to break the bonds. So for example, if we look at this single covalent bond between these two carbon atoms, what then happens is the bond breaks. So now we've got these two carbon atoms. Now total energy out is when new bonds are made, and this is the energy that is released. So let's say these two carbon atoms, they collide and they form a single covalent bond. It's literally the opposite. Now, energy change, if you have a positive number, this means this is endothermic. Okay, we've already gone over that. I'm not going to explain that again. So if you've got a positive number, then it's endothermic. If the energy change is a negative number, for example, minus 256 kilojoules per mole, we know this is exothermic. Whenever you write your answer for this, you have to always write positive or negative. You will lose a mark if you don't. I'm telling you now, you will lose 1 mark if you do not write positive or negative, as long as you get the correct answer. Okay, let's look at hydrogen bromide. When hydrogen bromide breaks down to form hydrogen and bromine. Now, I've actually got an introductory video on this that goes into the foundational stuff. I'm going to try and incorporate that into my teaching. If I was teaching in my class and I knew all of you and your abilities, I would potentially go through this, but that would take up a whole lesson. This is actually a whole lesson pretty much. So look, in your exam, you're going to be given bond energies such as this. You're not expected to, how many people are still here? 30 people, so a few people have left. Okay, so you'll be given these bond energies. You are not expected to remember this. So this is just telling us the covalent bond between a hydrogen atom and a bromine atom, 366 kilojoules per mole is taken in to break this bond, or 366 kilojoules per mole is released when this bond is formed. It's the same number. A covalent bond between two hydrogen atoms, 436 kilojoules per mole is taken in to break this bond. And also that's how much energy is released when forming that bond. And then also a covalent bond between two bromine atoms. So you need to look at that. Next thing, let's look at the balance symbol equation. We've got 2 molecules of hydrogen bromide reacting or breaking down to form 1 molecule of hydrogen and 1 molecule of bromine. Okay. Now, you can get a question which might say, calculate the energy transferred using the bond energies. And the question may also say, is it exothermic or endothermic, potentially? Now, how do we do this? In your exam, you would then be given a diagram, okay, such as this, where you are told, look, there are 2 hydrogen bromide molecules forming 1 hydrogen molecule and 1 bromine molecule. This you're most likely going to be given something like this. Any questions so far? Okay, excellent. So based on this, how many bonds are there between a hydrogen atom and a bromine atom in 2 molecules of hydrogen bromide? How many bonds of this bond are there in this chemical reaction? How many are there? 2. Thank you, Suleiman. Thank you, Vivek. Thank you, Sean. Thank you, Kelsey. 2. Thank you, Fatah. Look, 1, 2. Simple as that. How many covalent bonds are there? How many bonds are there between hydrogen atoms in 1 hydrogen molecule? What's the answer? 1. Exactly. Thank you. And then the same thing for bromine. Excellent. Now look, based on this, we know that in hydrogen bromide, 2 bonds will be broken. 2 bonds will be broken. We know in a hydrogen molecule, 1 bond will be made, and in a bromine molecule, 1 bond will be made. All we then have to do is now look at the bond energies and see that we multiply this number by this number, and this tells us how much energy has been absorbed to break these two bonds. So look, 366 multiplied by 2, because there's two bonds, excuse me, you always use a calculator to do this, 732 kilojoules per mole. You write this down because as I've marked plenty of exam papers where you get marked on these numbers. If I see that number, I automatically tick it. Then look, a hydrogen molecule, HH, there is going to be just one of these molecules with a bond like this. So we just do 1 times, or 436 multiplied by 1, which obviously equals 436. And it's the same for a bromine molecule, 193 multiplied by 1. We then do total energy in, which is this number, take away total energy out, which are these two numbers added together. So it's 436 plus 193. This equals 629 kilojoules per mole. In the chat section, what is the total energy change? What is the energy change? Off you go, please. In the chat section, write your answer. What is the energy change? Let me quickly calculate it myself. I'm not using my head, that's for sure. I can do it, but I don't want to make a mistake. Because this represents all the energy that was released when bonds were formed. So we have one bond made, another bond which has been made. This is the energy that has been released. And look, the equation says total energy out. So we are adding all the energy that has been released together, which equals 629. Oh, come on. No one's got the correct answer yet. What is this? People aren't listening to me. Is it an endothermic change or an exothermic change? How do you show that? Yes, Vivek, first one there. Well done. Well done, Hyjin. Well done. Oh, Sean. Thank you, Afifa. Well done. So look, it is, you do these two numbers, 732 take away 629 plus 103 kilojoules per mole, endothermic. So you have to have the positive sign. Okay, let's go to the next example. I'm going to throw you into the deep end. How long have we been going for? We've been going for 42, just 40 minutes roughly. Cool. We're going to do 2 questions, this one and then another one on top of it. Off you go, please. I'd like you to, here's the question, calculate the energy transferred using the bond energies. You have to use a piece of paper to do this. I'm going to give you a minute and a half. If it's not enough, you're going to tell me. Go. Any questions? No, it's exothermic. Overall energy change is always energy in, take away energy out. And if it's a negative number, then you know it's exothermic, Suleiman. Okay, I'm going to give you 20 seconds. Oh, thank you, Vivek, for not. K is the anglicized surname version of our surname. Okay, has everyone got it? Do you need more time? Write your answer in the chat section. Let's see what you got. Ooh, -324 -8. Okay, 2 people. I have no clue. Thank you, Fatah. Okay, +915 -1. Ooh, where have people gone wrong? Okay, so it's between -818 and -324. Let's go through it. So look, here we have 4 bonds of CH. Look, so this one right here, 4 bonds of CH. So we're going to have to multiply 413 by 4. Notice this is simple numeracy. It's just about understanding what to do. Here we can see there are 2 bonds of this double bond between 2 oxygen atoms. So look, there's 2 oxygen molecules. Here are the 2 oxygen molecules, and there are 2 covalent bonds. That is this one right here, 498. So we can see there are 2 covalent bonds being broken. 1, 2. And then look, there is 1 molecule of carbon dioxide being produced. Here it is. And there are 2 C-double-O bonds. C-double-O bonds, 805 kilojoules per mole multiplied by 2. 2 bonds broken. Oh, sorry, 2 bonds made. Apologies, 2 bonds made. And then look, there are 2 molecules of H2O, 1, 2, 3, 4 atoms between the H and the O. So look, 4 bonds made. So it's going to be 464 multiplied by 4. Hopefully you're looking at your answer and you're like, maybe I realize where I got it now. So I can see about 5 different answers there. Okay, so look, we do 413 multiplied by 4 equals 1,652 kilojoules per mole. So far, that's how much energy has been taken in to break the bonds between the atoms in a methane molecule. Then look, 498 multiplied by 2, that's how much energy has been taken in to break the two bonds in the 2 oxygen molecules. So there are 2 oxygen molecules, 1, 2, each having a double covalent bond. Total energy in is 1652 plus 996. This equals 2,648 kilojoules per mole. Give me a little yes if you are with me so far. If you got 2648 so far for total energy in. That's what I like to see. Fatah, you do have a clue. You're trying to tell me you have no clue and you're saying yes. Okay. Total energy out. This is now going to be using these numbers, okay? 805 multiplied by 2. So we're going to write that down. 805 multiplied by 2. And this is going to equal 1,610 kilojoules per mole. And then look, HO is 464. You multiply that by 4, 1,600. 1,800, do that in my head, terrible maths, 1,856 kilojoules per mole. You then add these numbers together to get 1,610 plus 1,856 equals 3,466 kilojoules per mole. Not hands up, it's as if you're in front of me in a class. In the chat section, give me a yes if you got 3,466. I hope Fatah makes sense now where you went wrong. If you said no, I hope it. No, even though it's double bonded, you don't multiply it by 4. No, no, no. Look, you use that diagram right there. O, double bond O. It's just 498. You could have a triple bond. It doesn't matter. It's just 498. You do not multiply that by 4. There are 2 bonds. 1, 2, or 1, 2. Okay, so it's 996. So 3466. That's your answer. You then multiply. You not multiply. You then take away 2648 because that's total energy in. 2648, take away the total energy out, 3466, which equals minus 818 kilojoules per mole. Big up, who got that correct? Big up Vivek and Alicia. Well done. And to anybody else who also got that, well done, Suleiman. Excellent. 464 by 4. Because there are, look, 4 bonds. 1, 2, 3, 4. There are 2 molecules of water. One molecule of water is H2O, H2O, 2 atoms of hydrogen to O. There are 2 single covalent bonds in 1 molecule of water, but there are 2 molecules of water. Do you see that? So look, 464 multiplied by 4, which equals 1856. Hope that's good. Okay, next, there's one more example here because I know people always get this wrong. So when I made this video, I was like, this is exothermic. Let me do one more example. Off you go. Oh, look at this one. I'm going to give you 2 minutes to do this max. Go. Thirty more seconds. I agree, Salim, and people are overcomplicating it. It's literally just simple additions. It really is. You get a number, you multiply it by 2 or 3 or 4, and then you just add them together, do a little takeaway. It's just about knowing the order to do it. Okay, I've had enough time. Let's go straight into the answers. What did people get? Write your answer. Write your answer. Sorry, Kelsey. Yes, you do get the drawings minus 210. If Alicia, Mina, and Vivek, and Aya, and Hadrian are getting this. Sorry, Fanta. Minus 210 kilojoules per mole. I'm going to very briefly go through this. We can see there are 1, 2, 3, 4 HO bonds. That's HO, so you do 464 times 4. Look, 464 times 4. And then there are 2 single covalent bonds between oxygen atoms. So it's 144 times 2. You then look at this. HO, there are 4 of these bonds. So look, you do 464 times 4, which equals this number. And then there is just one bond between 2 oxygen atoms. There's one double bond, 498 times 1. You then add these 2 numbers together to get this number, total energy in. You add these numbers to get the total energy out. You then do total energy in, take away total energy out, and you have to do minus 210. I pray, plus 352. Take a picture of your working out, Fatah, and send it to me at info@KayScience.com, and I'm sorry, no, I don't upload it to I don't upload it, no, I don't.